Today's topic is converting AC to DC and half wave rectifier. So to convert AC voltage into DC voltage, so we have the AC voltage source and a transformer. From that we give it to a diode rectifier. It may be either half wave, full wave or bridge rectifier, and then to a filter. It may be either a inductance, capacitance or LC, CLC filter, followed by voltage regulator, which may be either series or shunt voltage regulator. And finally we have the load, and across the load we need to get a constant DC output voltage. So half wave rectifier converts the AC voltage into pulsating DC voltage. It converts into DC, but it has ripple component in it. So this is the diagram. For the positive half of the input signal, so for this half only, what happens is this diode is in forward bias, and so we get the output signal as such. For the negative half of the signal, the diode is reverse biased, and so there is no output here. The ripple factor is the RMS value of the AC component divided by the DC value of the component. So it is VR RMS by VDC. Ripple is root V RMS square minus VDC square. So it is root of V RMS square minus VDC square by VDC. So root VRMS by VDC whole square minus 1. VRMS is square root of the area under the curve for one cycle divided by the t time period. So it is root 1 by t integral x of t whole square dt. So the DC current or average current voltage DC VDC is 1 by 2 pi integral 0 to pi Vm sin omega t d of omega t is the output, and from pi to 2 pi the answer is 0. So we integrate in this way. So this output is 0. So we have Vm by 2 pi. Sin omega t integral is minus cos omega t, and the limit is from 0 to pi. So in that we get Vm by pi. This becomes 2. And so 2 gets cancelled and it is Vm by pi. IDC is VDC by RL. So it is Vm by pi RL or Im by pi. And if the values of the diode forward resistance RF and the transformer secondary resistance RS are also included, so the VDC becomes Vm by pi minus IDC into RS plus RF, and IDC includes all the three resistances RS, RF and the load resistance RL. RMS voltage at load resistance VRMS is 1 by 2 pi integral 0 to pi Vm square sin square omega t. It becomes 1 minus cos 2 omega t, and on integrating we get the answer 1.21. So the amount of AC present in the output is 121% for half wave rectifier. Efficiency is PDC by PAC. It is 40.6% for half wave rectifier. PIV is peak inverse voltage. Maximum reverse voltage the diode can withstand without destroying the junction. It's Vm for half wave rectifier. Transformer utilization factor is DC power delivered to load divided by the AC rating of the transformer secondary, and it is equal to 0.287 for half wave rectifier. Form factor is RMS value by average value, which is 1.57, and peak factor is peak value by RMS value, which is 2. This is regarding half wave rectifier. Thank you.